Hi, this is Victor and welcome back to my math tutoring channel. In this video, I will solve those two problems, those two integrals. So let's start with the first one. The first one is integral of sine x divided by 1 minus sine x dx. If I look at that integral, if I say let u equal my sine x, my du will be equal cosine x dx, and I don't have cosine x in that integral. So let's see how we're gonna solve it. But I realize in the denominator I can make it a square minus b square. So, and then we can have cosine x. Let's see. So if I multiply by 1 here, I did not do anything, but I will write my 1 in an intelligent way, which is 1 plus sine x divided by 1 plus sine x, because a number divided by itself is equal to 1 dx. So my denominator, it is a minus b times a plus b, which is a square minus b square. It is 1 minus sine x square of x. And my numerator, it becomes, if I multiply sine x by 1 and sine x by sine x, it becomes sine x plus sine x square dx. But I know 1 minus sine x square is equal to cosine x square. I'm using that formula, cosine square of x plus sine square of x is equal to 1. So 1 minus sine x square of x is equal to cosine square of x. So my integral become sine x plus sine square of x divided by cosine square of x dx. And now I can distribute my denominator. It become sine x divided by cosine square of x plus sine x square divided by cosine x square, and all that is dx. And here I can write tan of x divided by cosine x, because sine divided by cosine is tan, and I still have cosine x in the denominator, so I added it, plus tan square of x dx. And I know one trigonometric identity that tells me sec square of x is equal 1 plus tan square of x. So from here I can deduct that tan square of x is equal sec square of x minus 1. So I will replace this tan by that formula, and I know that 1 over cosine of x is sec of x. So tan of x, instead of saying divided by cosine of x, I will multiply it by sec of x, because 1 over cosine is sec. And instead of saying tan square of x, I will say it plus sec square of x minus 1. Sec square of x minus 1. And all that is dx. Now I know I can write it into two integral or three integrals. It will become integral of tan of x sec of x dx plus integral of sec square of x dx minus integral of dx. I know that it's a formula. Integral of sec of x tan of x is equal sec of x. So this is equal sec of x. And I know the integral of sec square of x is equal tan of x. I will put the plus c at the end. So plus tan of x. And the integral of dx is x minus x minus x plus c. So my integral is equal to that, and that's my final answer. I will do the second one. which is 1 divided by 1 plus sine of x. Let's do it in a new page. 1 divided by 1 plus sine of x dx. Just to make sure I copied it right. Yeah. This is like the previous one, but I just want to enforce your knowledge about this. So I am going to multiply the numerator and the denominator by 1 minus sine of. So it becomes 1 divided by 1 plus sine of x times 1, but my 1 I will write it 1 minus sine of x divided by 1 minus sine of x dx. So my integral become 1 minus sine of x in the numerator divided, this is a plus b and a minus b, which is equal to a square minus b square, and I know that 1 square is 1 minus sine square of x, and I know that 1 minus square of x is equal to cosine square of x. So this is equal 1 minus sine of x divided by cosine square of x dx, and let's distribute my denominator. It become 1 divided by cosine square of x minus sine of x divided by cosine of x times cosine of x, which is cosine square of x, and all that is dx. And 1 divided by cosine square of x is sec square of x minus tan of x, and 1 divided by cosine is sec of x dx, and here I can divide it into 2 integral sec square of x dx minus tan of x sec of x dx, and it become like the previous. So integral of sec square of x is equal tan of x. I will put this plus c at the end, and the integral of tan of x sec of x is sec of x plus c. So I hope that you like my video. If you like my video, please subscribe to my channel. It will help me continue to do more videos for you. And if you like it, I would appreciate if you press on the like button. Thank you very much for listening.